Hello guys, and welcome to this video in which we'll be starting with chapter 5 lesson 3, controlling chemical reactions. So we're going to divide this lesson into two parts. So we'll be running the first part in this video and the second part in another video. So let's get started. First thing, or the first part, talks about chemical reactions and activation energy. So what's basically activation energy? It's the minimum energy required to start a chemical reaction. So in other ways, it's the energy that is needed for the reaction to start. Imagine you have a bus and the bus is waiting for passengers to get in. Now the captain of the bus will not go or start driving unless the bus is full. So if he says like, I want 10 passengers to start the bus, this is his activation energy. It's the minimum amount required to start something. In this case, it's the minimum amount of energy required to start the chemical reaction. So as you know from physics, you took it, energy is measured in joules or kilojoules. So this energy that's required, why is it there? It's required to break the bonds. We said previously that bond breaking happens in reactants. So activation energy is needed to break the bonds of the reactants. Now, activation energy, this one, is abbreviated EA. It stands for energy of activation to start the reaction. So what happens to the atoms of the reactants when they break? They form new bonds. They form new bonds where in the products. So bond breaking happens in the reactants, bond making happens in the products. Therefore, enough energy should be provided. So imagine a reaction needs 1000 kilojoules to start, and it's given 999 kilojoules. Will it start? Actually, no. It needs to be given a specific amount of energy, which is the activation energy, in order to start. Now, let's compare the two types of reactions that we already know and we already talked about, which are exothermic reactions and endothermic reactions. I want you to think about the difference between the two. So in exothermic reactions, I'm going to start with exothermic reaction. Energy is released. We said this previously, energy is released to the surroundings outside the reaction. So the temperature outside the reaction in the surroundings increases. Now let's take a look at the graph. If you look here at this graph, this is energy of the reactants, the specific energy that the reactants have. If I want the reaction to proceed, this is on the x-axis, we show the direction of the reaction. So here you have reactants, the reaction goes forward, and here you have products. So the energy of reactants is here. Once the activation energy is absorbed, the reaction proceeds. As you can see here, it reaches this point on which a complex is formed during the reaction, and then as the reaction proceeds, you notice here that the energy goes lower, 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 lower until the reaction ends. As you can see here, the energy of the products, this is really important guys, the energy of the products is lower than the energy of reactants. Now this is an indication that the reaction is exothermic. Why? Because the energy gap here that you see is the energy that is released from the reaction to the surroundings. So energy of the products is lower than energy of the reactants. So this is an exothermic reaction. The energy released is the difference between the energy of the products and the energy of the reactants. So energy of products minus energy of reactants will give you the energy that is released. Now let's check endothermic reactions. So the definition or the property is that energy is absorbed. Energy is absorbed or needed for endothermic reactions to happen. So because energy is absorbed, the temperature of surroundings decreases. It takes energy from the surrounding and absorbs it. So the energy outside is decreasing. Now let's check the graph. This is the important part here. As you can see here, this is the energy of the reactants. Now you see a high activation energy barrier that needs to be overcome. So the reaction cannot start until enough energy is provided, which is equivalent to the activation energy to start the reaction. Reaction starts, reactants break, the bonds in the reactants break. Reaction starts, it reaches the activated complex, and then bond formation in the products start happening. Now, as you can see here, the energy of the products is higher than the energy of reactants, which is a property of endothermic reactions. Why? Because as the reaction proceeds, it needs energy to be supplied all the time. So energy is being supplied to the reaction all the time as it proceeds from reactants to products. Now, this that you see here, the difference between energy of products and reactants is the energy that is absorbed. It's opposite to the one we saw for exothermic, which is energy released. So this one is energy absorbed. So the property here is that the energy of the products is higher than the energy of reactants. Okay, so let's ask ourselves a question here. Which type of reaction do you think gives the more stable product? Well, energy, potential energy or kinetic energy or mechanical or whatever type of energy. In systems, in chemical reactions, the lower energy is always giving the more stable system. So, because in exothermic reactions, the energy the energy of the products is lower than the energy of the reactants, so this is the least energy, it means that the stability of exothermic reaction is higher than the stability of the product in the endothermic reaction. So products in exothermic reactions that release energy are more favored. So this is the difference between endo and exothermic reactions. And this is the end of part 1 of this lesson actually. You have to solve page 183, ask questions, and figure 1, which is related to activation energy. Also you have on page 184, assess your understanding. Please solve these and send them on Edmodo during the first session or after the first session. So we'll stop here. This is the end of part 1 of this presentation. Thank you.